So I might get started here. It's going to take about 4 or 5 hours to get through. Seriously, I mean, we got a lot of good content here. You know, what? No chuckles? Oh, you're all mute. That's why I can't. You all applauding and laughing and saying this is great stuff here, Wes.
I'm sorry. That's my bad. I forgot the cue to guffaw.
You should have the canned laughter there.
Yeah, let me get on that. So it's ready next time.
All right. So what we want to look at here is the building life cycle of the projects, and for the commissioning, the performance assessment that is coming in for existing buildings to go in and see where the building is right now, what are the issues, what are we trying to tackle. But for this topic here for commissioning, we're going to be focusing on basic design through the commissioning process itself. And the basis of design is important, and it should be part of the commissioning process, because commissioning should start, pre-design. And we'll get into the basic design and why it's important inside here. So I want to start off with a thinking point. I know a couple of you have already seen this on this group. So I think Peter and Isaiah, you definitely have seen this, so don't give it out to Mike and a few others. The answers to this question, I updated with my new truck. Which is more efficient? And I know the answer to this one. Huh?
Well, it depends.
It depends. But this one here this is nice. Got to do 6.7 liter V8 turbo diesel in this thing, right? And it depends on who's driving it, how you're operating it. Because, with the Toyota Prius, it's been designed to be very fuel efficient. And, God bless them, they constructed it to be very fuel efficient. But if you put it in the hands of somebody who's not going to operate it in the right way, the regenerative braking system goes out the window. And I managed to get this thing to be about 5 miles per gallon. Whereas my new truck now gets 16.5, and sometimes I get up to 17.5 miles per gallon down the highway. What I could take out of this is that my truck gets a whole lot better fuel mileage than that Prius. But it depends on how you're driving it, right? So the same thing with buildings. We need to have a really good design intent, construct it well, and then be able to operate it well. So keep that in mind when we go through the entire process. I know, Peter, you've heard me say that a good few times, and Isaiah was a lot chuckling at that. So when does the commissioning start? Okay, so we're going to start to get serious now. It's quality control. And here's one of the sayings that Ken always says, did you get what you asked for? So if you're talking about, lead commissioning or someone asking to come on board at the end of the project where it's in construction, it's building's nearly built, can you come in and commission it? Well, the ship has sailed for a lot of the actual commissioning. It's like this horse race. What if that horse represented your building? The race is already nearly over. You come to the finish line. There's not much you can do to fix it or to improve the situation. We don't want the building to be the horse coming in last. That's not the performance goals that we want to have for the project. So we want to be able to shift that towards the front of the pack. But we can't do that if the commissioning is starting at the end of the actual project. Here's an example. We were brought into a project where they asked us to come in and commission a building after it was built and being operated. And for some reason, the electrical bills were substantial. All electric building, heat pumps to each unit, ERV, so it sounds good, but that ERV has got an electric resistance for the heating of the air. But the set point they have it at is that ERV is now heating the space in the building. And because it's overheating the halls, those heat pumps are actually not working or sometimes going into cooling. So the building's being heated by electric resistance and a whole lot of electricity. Ken, do you remember what the electrical bill was for this building?
They were paying
All right,
upwards of 10,000 a month,
Yeah, there we go.
10 to 14 a month through the winter. But
Uh,
it's exactly the system they designed, and it works as designed.
It works perfect. But would you want to have that? That's that horse coming in towards the end of the pack. But it's all electric, right? So the quality assurance, this is where did you ask for the right system? And there's two sides to this. It's owner's project requirement, base of design. So we're starting here before the actual design has even started. With the owner's project requirement, the client themselves need to identify, what do they want out of the building and how they want it to function. And that way it could be captured within the basis of design. The base of design would be a document to help guide the actual design team and the client. And I put in here for a performance project because we don't want that, electric resistance air handling unit making us lose the horse race. We're not going to win any money that way. So let's start here flushing out a base of design. If someone said to you, I want a building, well, great. We could give them a glass box and some boilers. Problem solved, right? Are we going to be good? It'll work. It might not be the most comfortable thing. Or if they started to flush it out a bit more, well, they want a building. It's going to be multi-story, about 5 stories. That's going to be the height requirement. And now you can start to flush out, so it's not going to be a school. It's not going to be an office. Now you get the building type. It's going to be apartments. We're going to have elevators inside here. And, what type of fire protection is going to be required. But wait, we want to have some solar on here. We want to start to project as if we're going to have some, sustainability here. So we're going to have some solar and offset some of our electrical requirements in the building. Okay. So we need to now know where equipment is going to be located on a roof. We got a cluster maybe on the north side of the roof, so it's not casting shadow. And that way it leaves a lot of the roof space available for solar. So the base of design now is starting to get developed so the design team could actually flush out the building. Oh, but wait a minute. The owner wants to reduce the risk and wants the building to be high performance. Maybe passive house becomes a goal that helps reduce the risk. So now these performance goals could be built into the actual design. And it gives a really good framework for the design team to take off and start doing the work of the design, right? We could now start to really feel confidence. We're done. We got this thing under control.
Maybe.
Right? Maybe.
I think you just got it to the launch pad, that's all.
Ah, damn. That's right. Maybe I'll think of the first Mars lander. All right. Well, now we need to get into the actual design phase because there's so much that could get lost. And we've seen this in a lot of projects where we have a really good base design put together with a client. And then the whole design phase goes quiet. And something totally different comes out. And it might even be something like that electric resistance air handling unit. We need to make sure, like belt suspenders, that the actual whole team are working together, and if they're possible even with a GC, to determine how this building's going to get built and how it's going to meet the client's goals. So Ken, this is one of your design reviews. Do you want to give a little example of this?
This is what happens when somebody gives me a simple detail. Jose has been there before. He's had to endure this. But essentially, part of the commissioning agent's role, right, is to ensure that the owner's objectives are being met, because the owner may see this detail. Well, they're unlikely to look at these kind of details, right? And they may be none the wiser. Yet we don't have too many clients, developer clients, that are also really sophisticated in terms of building technology. Typically, their expertise and their value is in a different field. So
that is, it's a shared clock.
Yeah, sorry, I missed that one. Jump in anytime if anybody's got a question or comment. That's part of what makes this fun. But so this is part of the as I was saying, part of the commissioning agent's role to recognize issues in the design if they come up, and to be able to speak for the owner and steer it towards the owner's objectives.
And part of this is a big team process. And this is, of course, these pictures here are not recent. A lot of these now are happening on Zoom or GoTo meetings. It used to be fun too when we used to be able to get with a whiteboard in the room and just be able to sketch out ideas and have lunch together. But here we have examples of having design teams and contractors, design build team, all together in one place and go through these ideas and making sure that, well, how do you capture these basic design ideas into an actual design that can be constructed? So like the picture here, look at the wrong screen, here is actually, you have a design build team, architect and the builder, and they're actually sketching out ways that, how do you actually make the enclosure work, and in a way that they're comfortable with building, and that could be done for that project. It's a really good way of having a handoff between the team members. Okay, do you want to add anything to that?
The image on the left makes me a little upset because everybody else is having lunch, but I'm not.
You were on a diet that week.
Was I?
Yeah. So there's different types of commissioning. And we're going to get through a few different types, and the most common ones we're going to have examples of projects. So, oh look, a cameo. There's Liam. There's commissioning. There you go, Liam. Welcome. And what commissioning is to verify the building systems perform according to the owner's project requirements and basic design. So it's not just about making sure those that meet the actual drawings. It's let's step all the way back to and flushing out what the owner actually wants and requires. Make sure that's in the design, and then make sure that's in the actual, that's how the building actually performs. That would be the overall goal.
And Wes, do you want to talk a little bit about the difference between TAB contractor or test and balance contractor and commissioning?
Well, the testing and balancing contractor is someone who's going to try to balance out the flows of the hydronics and the airflow in the building. They come in at the very tail end and try to get next would be a really good example of one in a way. They're going to try to get the airflows and hydronics to what the design had on the actual paper. And I did a presentation in front of the NEB conference back in Albuquerque 7-8 years ago. What year it was. And here's their perspective where the design has been complete, the construction has been complete, and now they're required to try to balance it as per what the numbers say in the drawings. But it's difficult to balance it when all those ships have sailed and now everything is finished. The commissioning is we are doing spot checks of, like say Liam right there, he's doing some spot checks of the balance of what's coming out of that air, what airflow is coming out of that diffuser. We are not trying to balance it. We're seeing where the air is coming out, how much the system is putting out overall, where there could be issues, and then helping guide the owner and the TAB contractor, the overall mechanical contractor, to help solve the solutions or problems to the building.
Okay.
The TAB contractor, in this case, might be coming back and rebalancing this system that is not functioning. This one in particular had 7 CFF at one of the locations where it should have been 200 that Liam measured.
Right. So in a way, there's some overlap with test and balance. But one way that I think about it is that when you're doing functional testing as part of commissioning, it's a whole lot of signal and response. You throw this switch and see what happens. Tell the sensor that it's 40 degrees in the room, and does it kick on the heating? And just kind of running the systems through their paces. It's like a test drive. Except
see where it falls over.
Yep.
Well, you mentioned tabs because here's where it's kind of the overlap. This is a project where it's a recent enough one. There's comfort complaints in the building, and we weren't involved in the actual project till after it was built. Asked them to come in and trying to help diagnose the problems. And as you can see on the, oops, sorry, why is it jumping on me? As you can see on the actual, this is like we talked about with the tab contractor's job is to try to balance out this diffuser to make it to 180 degrees. Oh, sorry, 187 CFM. And there's volumetric dampers to be able to adjust each one of these to get the appropriate amount of CFM to come out of each diffuser. And the intent would be is that this fan coil unit could provide enough airflow and pressure on the system to balance out the system to the perfect design requirements of, in this case here, 1200 CFM. And this unit, the bedrooms are reporting that they're cold. They don't reach temperature during the wintertime. So we had the tab reports and the drawings of the building. We went in there to see what's going on. But unfortunately, the only thing you can see are the diffusers, the ceiling. It's all a gypsum, hard lid ceiling. So what do you do when there's a hard lid ceiling that you can't see above?
You get the hammer saw out and you make some holes.
Got it.
Ah.
Yeah. And look, we found the duct. So here's the mysterious duct that we're trying to find. Well, we were able to drill a hole in it, and through that hole, we could then put the borescope and feed it down the duct line and find that they didn't have turning vanes in the actual 90 degree. And on top of that, there's no volumetric dampers. So when taking out the actual, looking back from the diffuser back to the actual mainline duct, there's no volumetric dampers. Okay.
So did the tab contractor mention that in their report when they submitted their invoice?
No, but the CFMs were pretty spot on to what they should have been.
Okay.
So moving on to what is actual. Well, a few things had changed. The fan coil unit is now going out this direction, doing a hard right. And all those volumetric dampers that you see, I put the big X's over them, they don't exist. And when we actually did measurements on it, bedroom 1, there's no complaints. So with the 94% of the airflows, 6% low. That's not too bad. But if you look at the open plan space here, 46% over, 33% over, and 32% over on CFM. That open plan space is sucking up all the air, basically. And if you look at these 3 bedrooms at the end of the line, they're under capacity. But overall, it's within 7% of the total system. So if you're just looking at the overall airflow, it looks good. But it's not getting to where it should be. So this space here where the thermostat is, gets too much air, gets satisfied quickly. These 3 rooms down at the end don't get enough air, and they're cooler than the other locations. What's the moral of the story? No? Got holes in the ceilings.
Oh.
Ah, okay.
Right.
And put volumetric dampers in.
What did the testing and balancing report show? Was it just what the fan coil unit was putting out as a total, or was it actually individual readings for each of the elements? So did they show this?
They showed, not in green. They didn't have a green box like this, but they had a white table. And it showed like design versus actual, and they all looked like this.
Yeah, okay. That's the testing and balancing reports I've seen. They always are like 1 CFM off, as if they balance them exactly perfectly. So.
Yeah.
Yeah.
So with the volumetric dampers, I don't see how you could balance them.
Yeah.
One of the morals is if you're going to rely on volumetric volume dampers, whatever you call them thingies. If you're relying on manual dampers or some sort of control, there needs to be access provided. That's one of the things that a commissioning agent could see in the design phase. You look at the reflective ceiling plan. Does it indicate that there are access panels in the ceiling? If not, it's probably not happening. Even if the dampers are there, nobody's going to use them.
Yeah.
Unless they're really small.
I was talking with the owner about this. Like, even if you went back and retrofitted these things, do you want to have 7, 8, 9 access panels inside your living room on each apartment? Probably not. So there's other ways of doing it, such as restricting it at the actual diffuser, putting in a car damper in line with the duct at the diffuser. That way you don't have to actually damage your ceiling and pull the whole thing down or put in access panels everywhere.
It's a good retrofit solution, but also if we were on this, we probably would have recommended it as a design solution.
Okay, so that was things are missing. How about one is things are added? Okay, going back to back on this. So you can see there I am standing in front of a boiler. Okay. And this project here, it's kind of a bit frustrating for a little while. You know, I don't know if anybody's used these newer lock and var boilers. I think they're pretty cool. They got nice control on them where you got this, instead of having like that clunky LCD screen, you got this nice screen on the front where you could see what the actual reset schedule is. And you can just put your finger on it and drag things around. It's like using not as good as, but like an iPad. Except for there was one issue with this, 2 buildings built the same way, or they're not the same building, but same boiler plants. This funky thing going on. No matter what, it would not get over 130 degrees. It just flatlined. And you can see the outdoor air temperature. You know, it's getting 32 degrees, getting down to 0 degrees, going up to the 50s, and then coming back down again. And the whole time, target temperature and actual is in around that 128, but the target's 130. But look, the day I'm here, it's 153, and it's still 130. Man, that was frustrating. Entire time there, just touching around with that screen, calling the lock and var boiler rep. He's telling me, well, just keep on going up with that reset schedule. Well, I was. Well, it's going to supply hotter water. Well, it's not. So went around for a while. Then we were digging around that boiler plant, and then it's like, what's this box in the wall doing here? This is not in the drawings. What's this panel here? And the mechanical contractor is a really nice guy. His guy's named Mark. We got on really well. He likes big trucks too. And he said, "Oh yeah, well that controls the pumps in the boiler." Like, well, why does it control the boiler? He's like, I don't know. It controls the pumps for differential pressure, and it tells the boiler what to do. Okay, let's look into it. Well, you can't really look into it, tell the controls. You need to have your laptop out, put the special controller on it. So we ended up doing that. He got his laptop out. Oh yeah, that thing sends a permanent signal for 130 degrees to the boiler. Like, so how do you change that? Well, you can't unless you have his laptop there to change it. So, like, well, this is not going to really work all that well. It's going to get cold outside. The building's going to get cold, and people are going to complain. And then what's the advantage of it when it gets warm outside and be able to reduce the temperature? And how could a maintenance person be able to actually adjust the set points here? So part of this was that the actual design didn't really have a sequence of operations. So in all fairness to the contractor, they came up with their own to get the building to work. But we just sat there and sketched it out with them. What did they actually need to do there to get the lock and var boilers to take over control of their pumps, basically flip the control. So their pumps weren't controlling the boilers. The boilers were controlling the pumps BAS. And it was like the aha moment that we could now get this thing to actually work the way it should have. But it took a long time to get there. And it took probably a few weeks of working back and forth with them before they figured out why they needed to actually implement it. But it was good fun. Always is. I'm going to set the next one up for Ken.
Oh boy.
Yeah, look at that.
Okay. So I think this is this might be an example of, a good contrast between did you get what you asked for or did you ask for the right thing? So it looks to me like this this design here called for a fancy air and water barrier fluid applied on the exterior sheathing. It looks to me to be there, right? So it's making that gypsum sheathing even more airtight than gypsum. That was a joke. Gypsum's already pretty airtight. But okay, so we've got this air and water barrier on the gypsum. Do we have an airtight building?
Anyone? Bueller?
No.
Anyone?
I'm gonna guess no.
I see Liam shaking his head. Yeah, he knows where we're going with this. Yeah, do we have an airtight building? Well, no. You've got that nice airtight pookie all over the sheathing, but then the sheathing comes down and the back side of it is open to the garage. That ain't gonna work. And then you also have that part that's open to the wall and all the, I guess you can see, can I draw here, Wes? You'll let me draw?
Let me, hold on.
Hold on.
We figured out how to
All
do
right,
it the
look
other
at
day,
that.
right? There we go. Try it now.
Okay. Oh yeah, this is gonna be fun. Okay. So yeah, so we've got that nice airtight thing on the outside, but we know we've got a nice air path there. We've got air path going all along these fireproofed pieces of steel framing, right? We're gonna line them up with some gypsum, which is relatively airtight, but then we still have basically these metal frame walls, which are, as we know, kind of like ductwork, right? So we have everything kind of interconnected here. So this is something that, it's all well and good to, I could picture, I guess, somebody bringing out and doing some ASTM testing on that wall system. Can anybody tell me what ASTM stands for? Anyone? Come on, come off mute. And Peter, you know what it means.
I'm not quite sure what the M is. Another stupid test method?
Yes, another stupid test method. So we could go ahead and do a whole bunch of pull tests on that black pookie and make sure, yeah, that's good and that adheres to the gypsum. You're good. You got a great air barrier. We can even test the seams, make sure they got that taken care of. But that doesn't do you much good if you don't have something that's air sealable. So you can bring a blower door out and test whether you're air sealed at the end, but you really need to back up to the design phase and the construction phase to see, do you have something that you can even make airtight? And that's where we probably need to focus rather than on the fancy materials and membranes.
You could focus on the positives. It's a really good WRB.
It's a great WRB, yeah. And you don't get reverse lapping, right? You don't have it. It's not, as we know, like good, bad, right? You don't get reverse lapping with the water control with the fluid applied. That's a really good point. I will notice that they took the fluid applied over the bottom plane to the windows, which of course is going to make me a little grumpy. But yeah, that is a good point, Peter. It's not a bad system for that, but to get the value out of it, we need to think of the whole system and what we're trying to achieve. And thanks for speaking up on that. Okay, so I think mock-ups are hugely important. It's like you go through all the phases of design, schematic design, design development, construction documents. Then there should be another phase called mock-ups, where we see if the design works. Often the mock-up is done to test the finishes. We want to see the color, how that looks in the light, how these things go together, the tolerances that we have for the sealant gaps. That's great. We think that the mock-ups should also be functional. So you can do a functional test on them. So here's where we're doing a window install. And we've got a big building, lots of windows. You go and get a subcontractor who's going to install the windows. Yeah, we're going to install the windows just like we always do. No, you're going to install the windows according to the details. Oh, no, we've done this for years, never had any problems. Okay, well, let's just see if we can do what's in the detail here. So typically, it's getting a little bit better now. You'll notice on the right. So this is one of my pet peeves. Typically, you're going to see people, and this is what the contractor did during the mock-up. They're going to put what's going to happen here, Isaiah. Isaiah, are you with us?
I'm here. What's the question, Ken? What are they going to do?
Yeah, what do they typically do here?
They put some Tyvek up on the outside and they tape to the flange.
Oh, yeah, they're going to tape all four sides, right?
Oh, yeah, yep.
That's the way we always do it. And all right, well, that is typical practice, but it's not good practice because we need the window opening to be able to drain, right? If and when, or when the window fails, water needs to get out. Also, another thing, this is a cool trick. You can go to a site, when you see tape across the bottom flange and it's been there for a few days and it's winter, go ahead and pull that tape and tell people that water's going to run out, and then pull it, because I guarantee you water's going to run out. Because if it's cold, you're going to have that flange, a whole bunch of condensation collecting on the back of that flange. You can pull the tape, water runs out, and you look like a magician. That's just a fun building science trick that you can play on a site. So anyway, the window needs to drain. So we get the contractor, hey, pull that tape off, and then always bring a water bottle with you so you can pour water in the window opening and verify, as we do with these water droplets here, verify that the water leaks out. But then, all right, that's all well and good. We're commissioning agents, we're geniuses, we always have the answer, except for when we don't. And in this case, the commissioning agent, real pain in the butt, he wants a back dam, right? So he wants there to be a back dam underneath the window so that water, if it goes under the window, it goes out instead of in, right? That seems a reasonable request. Of course you want a back dam, except if there's a back dam there, how is the installers guys, how are they going to get their fingers under the window to move the shims around? Oh, so it's really useful, back to that, if you think back to that slide that Wes had about the integrated design process, where you had the design team, the owner's, the commissioning agent, the owner's technical rep, and the builder, because you need somebody to say, to be able to speak to the implications of the constructability of it. So in this case here, we came up with a way of putting, all right, we'll compromise a bit on the back dam, pull it back, give room for the workers to get their fingers under there, move the shims around, water drains out, they get flashing under the window, everybody's happy. Sound good? Cool. All right, moving on there, Wes.
All right. Moving on. Oop. Moving back. Moving forward. Technical difficulty.
Doing the two-step already there, kid.
That's right. Okay. So retro commissioning. Difference between this and commissioning is that the building is existing. It's out of warranty. Contractors are gone. They're demobilized for, could be a year, 2 years, 5 years, 10 years, 50 years. And you need to go in there and commission it, test it to see does it actually meet the original design intent, or does it meet what it's being used for now, basically. And this at times could be a little bit more difficult, but also more fun. With commissioning, where it's new construction or newly renovated work, you still have the contractor there to help out on anything that goes wrong or anything that you find is wrong. In retro commissioning, you are the detective that needs to figure out what's wrong, how to diagnose it, come up with solutions to fix it. There is no fallback on it. So here's an example here where we have this boiler plant with these two large easements. They have enough capacity for the building. It's actually 3 buildings attached to each other, an old mill converted to multifamily. But yet, one of the 3 buildings is not getting enough heat on cold days. So, what's the problem? And we're down there taking a look at this to figure out, why is this building having issue? Is it an enclosure issue? Is it a boiler issue? Is it what? So we go down there and take out our data loggers. Love data. Love looking at data to figure out how buildings are operating or not operating. And we put a data logger on each one of these 2 boilers. You have boiler 1 and boiler 2. And guess what we find on how they operate? Did someone just color that in? I mean, this is telling me whenever it spikes up, it tells you when the boiler turns on. And when it spikes back down, it's when the boiler goes off. And when you see it going up and down a lot, the boiler's kicking on and off, on and off. As you see it goes into the season, it gets colder, boiler 2 turns on and stays on. Besides a couple little blips here and there, boiler 2 is pretty much just chugging away, never turns off. Boiler 1, what is going on? It is pretty impressive. Blow it up into a shorter segment. That thing was turning on and off about every 3 minutes. The entire season. Now, I don't know if any of you have ever went out. Huh?
That can't be good for that boiler.
Well, I was just going to ask if anybody's ever went out to their car, sat down their driveway, just turned on the key, turned off the key, turned on the key, turned off the key, back and forth for the entire winter. Did they have a car left by spring? It's not really good for any type of mechanical system to do that. I wouldn't advise just doing that to prove me wrong, by the way. All right? So why is it doing that? So we started looking into different ways, different problems that might exist there. But one of the things they've been having problem with is the pumping. 2 pumps, one's failed, so 1 pump. And that's 1 pump. Now you got 3 buildings, north building, east building, and south building. South building being the biggest building. You have 2 boilers, 1 pump. That's it. Boilers don't have pumps, they're primary only. But then they break off into 3 loops and come back to the boilers. And there's this weird little go-between to try to bypass one of the south building to reduce pressure. And we monitored the temperatures of all these loops over the space of, like 5 or 6 weeks to see how they're operating. That's when we monitored these 2 boilers. And yeah, we found out that they weren't operating all that well. And it was pretty good reason why. Well, if we start to look into it, build the south building, which gets the water off the boiler system first, it's okay. It's satisfied. The boiler that gives out hot water, it gets hot water. When we get to the east building, it gets a few degrees colder. The north building is 10 degrees colder. That's the third one takeoff off the building loop. Uh-oh, there's a flow problem, right? That same flow problem is also what's causing that boiler to short cycle. It's not getting enough flow through the boiler. So the boiler is shutting down in safety every 3 minutes, burning itself out. So it's not injecting enough heat into the loop, but also there's not appropriate flow going out to the three buildings. So it's like, all right, mic drop. Now that's the issue. It's just the boilers and pumping. So they did actually upgrade that system by making it a primary, secondary, tertiary, and putting in a dedicated boiler pump for each boiler, making sure there's adequate amount of supply going through each boiler. And then there's a boiler room loop that circulates water, and 3 takeoffs, one for each building, each one with their own pump, to make sure each building gets the appropriate amount of GPM. And that did help out with the problem and solve the, that north building being less temperature than the other 2. But is that the only problem going on here at the facility? Well, no. That north building is also unique. It sits up on stilts. It's got a garage underneath it. So all 6 sides of that building cube is losing heat to the city around it. And they didn't do an overly impressive job when they did a new enclosure to the system. And that heating system runs as a ceiling heater inside the ceiling of the open air garage below it. Ah, that's why that building needed extra heat, because it's heating the city, keeping everything toasty around it. It's like above ground ice melts. So there's a lot of reasons why things are connected, not why they're not working, not just a simple, a mechanical fix. There's more things to happen in this building. Stay tuned. Recommissioning, we're going to just highlight on this. Recommissioning is, now you have the building commissioned, or it's been retro commissioned. Don't wait another 20 years to do it again. Pick a time frame of 2 or 4 years like that and get checked out. Again, this is a building that we went back to after a few years to make modifications to again, try to get to work better. And real-time commissioning is where you're monitoring the data on a regular basis to make changes to the building. So you're not waiting the 2 years for recommissioning. You're doing it on, as you see a problem, as you get an alarm, you're making changes to the system. Is there any questions on that so far, on different types of commissioning, before we move on?
Well, that's just on the real-time commissioning. You may see a spike in energy, or energy use, but also there could be any number of different parameters that you monitor that signal some type of alarm, and you got to figure out why that alarm was triggered.
Yeah, it could be energy, it could be temperatures, humidity, CFMs, building pressures. For example, one building that I'm helping out with right now, it's actually pressures is what we're monitoring, because the building is so sensitive with pipe work that if it gets over too high of a pressure, they could blow a riser. It's like a high blood pressure building. So yeah, we got to keep the blood pressure down on it. This one here is actually temperatures, and what we're monitoring here is when the temperatures get too low in heating. When the fan is on, but the temperature coming off that fan coil is getting too low. This person is complaining that I feel cold drafts at nighttime when I'm sleeping. So we're able to monitor when is it happening, and try and put the piece of the puzzle together is why does this keep on occurring with this particular system? Try to come up with modifications to the controls. But it could be, as Ken said, it's a lot of things, not just energy consumption.
When you're talking about real-time commissioning, are you talking about like just kind of a continuous monitoring of your building? Or are you talking about just fixing problems as part of like a retro commissioning or commissioning activity?
It gets into more of the actual monitoring.
Okay.
The retro commissioning, yeah, go on.
I mean, who do you like to do these? I mean, I've seen a lot of different companies who are like, hey, we'll monitor all your systems, but do you guys have a preferred vendor, or how do you guys prefer to do that, I guess?
It depends. It's not necessarily a preferred vendor. It's usually the building is set up to already have a BAS in it.
Yep.
Or, for example, it might have a VRF. So like Mike's here, it might be like a Mitsubishi or other type of VRF system. And it might have some other type of BAS layered onto that, where you could be downloading trend data and seeing how the systems are operating on a regular basis. So you're not waiting a year or months. You could be looking at this every week to monitor how the system's operating and continuously tweaking building operations. Similar with anything with monitoring makeup air systems.
Would you like your is this kind of something that you see building maintenance doing, or is it kind of a third party?
If you could train the building maintenance to do it, but what I find is that building maintenance are usually overtasked already to try to keep the building going, to add in another layer. Getting the alarms when something goes wrong, but not overdoing the alarms, because then they end up getting just silenced or turned off. So that's what I do fear with the maintenance side of it, is that if they get overwhelmed with too much of it, they'll just turn it off because they have too many other fires to put out instead of just trying to perfect the system.
Sure.
See it more of a third party, because then you might find something that's more like the underlying science of maybe it's not the mechanical system that's going wrong. Maybe it's the enclosure that has an issue, but you're finding it through the mechanical system and its controls.
Yeah, I mean, data is great, but you have to have somebody who knows what the hell they're looking at.
Exactly. It's pointing you in a direction.
Yeah.
Like a compass, but you need to know where to go. Okay. This part here is HVAC or enclosure. So it's kind of leading into that discussion there, Isaiah. So
it's going to be a game.
What's that?
Are we going to be able to play a game here?
It's kind of like a game. You
All
can
right.
take a guess of what you think it is.
Okay.
All right. Failing pipework, mechanical or enclosure? And any of you like horse racing? Yes, no, yes. Do you understand what these are?
Yes.
Horse blinders.
Yes.
Make you look straight ahead. You don't focus on anything left or right. That's your goal. That's your target. You're going straight for that. So when you're looking at buildings, we tend to put on our blinders. Oh, there's a problem. Where then the solution is going to be one particular thing. And what we're trying to do here is take off the blinders, because a lot of things are connected. Okay. So take a guess. What's causing that pipe to corrode? Anybody? Moisture? Yeah. So is that enclosure or mechanical issue?
Liam's got something. What is it, Liam?
That would be mechanical.
Mechanical.
I remember the same.
Darius?
I was going to say it might be enclosure, because the enclosure would affect the humidity levels.
Okay.
I'm going to say electrical. They got some stray currents, and they're carrying a whole bunch of amps, and the hydronic pipes are acting as the ground.
That's a good one. We've had one like that. Okay, so let's get technical here.
Middle range.
We got to take the blinders off when we're looking at buildings and look at everything. So we need to, oh shit, how'd this get in here? Ah, well, it's a picture of Ireland anyways, guys. So everybody.
Oh, what a surprise, Wes. A picture of Ireland.
I know, I
You
was
didn't see
surprised.
this coming.
I didn't, nobody saw this coming? Okay. Well, here I am. No,
That's the building real far away in the distance.
real far away. Yeah.
There are buildings.
Yep. Yeah, looking down towards Liscannor there, down the bay. So, you know, it's nice you take your blinders off and you take a look and enjoy the view, isn't it? But the thing is, though, is if you actually really take your blinders off, that's what was behind me when I took that picture. So you need to turn around and see everything in order to get the holistic point of view on things, right? Or else you got to miss the real picture.
There's more.
Just lining up on that, huh? So, what's going on with that pipe work now that you get the dramatic point I'm trying to make, right? Failing pipe work, enclosure. Well, here's the thing. I took this picture here is from a garage point of view, but same thing on the front, but it's just got a little bit of hard lid ceiling, but it's actually overhanging the building. You got like 28 risers going in the building, and you have that riser going up, failing insulation on the pipe work. It's leaky air, warm, moisture. Warm, moist air goes up in there in the summertime. 2-pipe system does heating and cooling. That pipe works cold. It gets attacked by moisture. Moisture starts to corrode the pipe work. So it's an enclosure issue. Yep, that's right.
So we have a winner. Darius is the winner.
Mechanical. This is the beautiful chiller that was there. Can anybody read the dials, or is it too small? This says, I love the accent on it. Kinda good. NG, very good. Almost good. So there was the 4 compressors on it. It wasn't able to keep up with the actual cooling load. It could maintain temperature.
That looks like 3 compressors to me, Wes.
Well, almost good. Yeah, kind of like 2.5. And leaking.
What's NG? Not good?
Not good, yes. Not good and almost good on this side. So when you have this, and you know, it should be keeping the water temperature down into the, like, say 44 degrees on the chiller. It was in the 50s. It just couldn't maintain the space, the temperature of the water to maintain the space conditions. So the makeup air unit would be turned off because it couldn't maintain the air coming in. It was able to maintain the temperature, but not the humidity in the building as well. So, you know, the sensible load would be taken care of, but not the actual latent load. It'd be, you know, 70, 72 degrees in there, but very humid. All right, so it's also a mechanical issue going on inside here. So trick question, both. Let's see, actually, some of you guys have been up here on this project with me. Who remembers this one?
I remember that one.
2 head nodding.
Sugar River Mill.
Yes. All right. So maybe 2 of you are barred from answering on this one. Enclosure or mechanical? It's got high energy use.
Is that associated with any air quality issues?
Well, there's got to be indoor air quality issues. Liam takes out the bat. He's swinging. You got an answer. Okay. So going in there, because it got high energy.
Hold on. We gotta get some answers here so we can tally it up. I'll keep score.
Okay.
So, Liam, what's your guess here?
I'm gonna go enclosure.
You're gonna go enclosure. All right. Isaiah, you're disqualified. Darius.
It has to be both, but I'm just gonna say mechanical because of poor, inefficient systems, maybe.
All right, Mike Reagan, you want to weigh in? Well, he's coming off mute. What about you, Peter?
Enclosure.
You think enclosure? All right, Scott, Fay, or caller 3. Do you guys have a guess for us?
I'm sorry. Is there a category for both?
Of course there is.
There's the guess. That's a smart answer.
Good edge. All right, we'll put you down for both. It's kind of taking the easy route, but it makes sense.
Yep. So going in here, because they have this building runs off of propane. There's a campus, there's a few mill buildings running off propane, and they have a high cost operation. So Peter came up with me in one of the times, and Isaiah came up on another time as well. But my first time walking in here, I noticed a few things. You walk in, and there's that big old like Home Depot bucket of air fresheners. They aren't taking one air freshener out. They just cut open the lid off the air fresheners, put it in the elevator. And there's air fresheners in the stairwell. And the stairwell doors are open to promote airflow through the building and make it smell a bit nicer. I'm like, there's an indoor air quality issue going on here. Okay, so I start walking towards the boiler room, which is on the lower level. And I get down there and I realize any of the boilers in this facility, this building, the other building, warm weather shutdowns not really implemented. The outdoor air temperature resets not implemented. Pumps aren't controlled. They're just on at full speed, even though they're variable speed. So it's kind of like one of those things like, well, these things are able to produce 180-degree water when it's 75 to 80 degrees outside right now. Well, not right now, but like in the summertime. Oh, there's a big problem. Okay, we can fix that. And the actual the maintenance guy says, okay, I'm going to leave you alone now inside here. And he had to go fix something else. But before he left, I said, well, what's this hatch in the floor? Where does it go? He says, oh, that goes to the dungeon. Oh. He said, we don't go down there. I'm like, okay. So I wait for him to leave. Once he gets necessary distance away from me, I pop open that hatch, see what's down there. Of course, yeah. I mean, you tell me it's a dungeon, I'm going to take a look and see what's going on. So it's a ladder going down, and here's that boiler room that I was in, and there's where that stairwell is going down too. So it's interesting. If a river is flowing by and it used to be a mill, what are the odds that it still is going underneath the building? Yeah, so it's ponding underneath it. And from underneath, when you're down in that dungeon area, as they call it, it's still very leaky to the spaces above. There's penetrations from old pipe work. You can actually see there's bottom of the elevator shaft, which is some insulation wrapping around it, but still leaky. So not necessarily the nicest place to be in, and nicest place for air to be leaking into the building from the bottom. And then later on, I was up in the attic. Ken, and Peter and Isaiah and anybody else, how air sealed do you think this space is?
Oh, that was terrible. That was the access to the attic. It was in through some old lady's closet. You moved your clothes out of the way, and there was a piece of sheetrock held in with like 2.5 screws, and you pulled it off, and then you walked into the attic, and that was it. And then we lost some lady's cat in there.
I'm surprised there was sheetrock. I'm picturing just cellulose on, ACT tiles.
Yeah, the access was on this wall plane here. There was a sheetrock through here, and to get in here, you'd walk with this catwalk. Her apartment's bedrooms were upbuilt into the roof. But it was pretty leaky. So to get back to a little bit of basics here, why is this important is the stack effect, where, we're in heating season and the bottom of the building's on negative pressure, the top of the building's on positive pressure, somewhere along the lines of negative, a neutral plane, and the air is going to be coming in through the cold air through the bottom of the building, working its way up, and then trying to escape from the top. Kind of illustrated a little bit by this scaffolding that's wrapped around here, right? You can see it kind of bellowing out towards the top and sucking in around the frame towards the bottom. Well, how does that relate to this building? This is kind of what's going on within that building. So in that dungeon area is where the air intake is. And the exhaust kind of is through that roof area, the attic location. And it's allowing the air to circulate through and out. And being disguised by all the indoor air, by all the air fresheners along the way. So it's an energy problem, yeah, but it's also a few other problems along the way that might be more important to tackle.
So, Wes, what do you think then? Mechanical or enclosure, or both?
What do I think?
Yeah.
It's both. Faye was
Both.
right.
All right,
We should
so
have Faye.
get a point to Faye there.
I get a cookie?
We'll arrange something. We'll probably send you some virtual kudos.
You know, I can take anything. I don't get much.
All right. Okay. We'll take care of you.
So, just want to finish off here on that. Everything that we do, either learning ourselves or the buildings that we're in, we need to be able to adapt to the future. And keep that in mind when we're looking at things. Some of you have seen this in my presentation before, but this is Holy Cross Abbey over in Ireland. It's been the same for over 800 years. That's where I got married. It's been an abbey. Now it's just used as a church, but same type of use, same type of operation, same materials. It hasn't really changed much, right? Not many buildings that we're working in or living in or working on have the same history or story as something like that. Usually they're adapting and changing all the time, and we need to make sure that the systems that we're putting in and that the techniques we're using could be able to adapt to the future, not just be stagnant to now. There's some examples of where the adaptability was not all the best along the way. I don't even know if they had good intentions sometimes. But we don't want to be stuck with something that cannot adapt anymore or is no longer useful. So let's keep that in mind for projects going forward.